Hello students, this is Mr. Anderson coming to you with a lesson on order of operations. What you need to understand at the end of this lesson is number one, you need to be able to show multiplication and division using numbers and variables. You need to evaluate and express numbers, and number three, you need to be able to use the correct order of operations to evaluate expressions. Before we get to the calculation piece of this, we do need to understand some basic vocabulary. This first one is this idea of what an expression is. An expression is just an operation with numbers, variables, or it can contain actually both numbers and variables. Let me give you an example of what I'm talking about here. If I give you, let's try this again. If I give you something like this, 2x plus 5, that is an example of an expression. So this isn't an expression. Let me show you something that would not be an expression. 2x minus 3 equals 8. This is what we talked about, what I wrote here in red on the right-hand side. This is not an expression. This is what we call an equation because it has an equal sign. An expression does not have an equal sign. See, with expressions, we have to evaluate those things. You cannot solve an expression. You can only evaluate them. And all evaluate means is to find a numerical value for an expression. So if we go back and I say, okay, here's an expression. 2x plus 5, and I'm going to tell you that the value for x equals 2. We should be able to evaluate this. So what we're going to do, and the way we're going to do that is we're going to replace 2 in for the x, or substitute 2 in for x. So what you really have is 2 times 2 plus 5. And if we were to evaluate that expression, you'd actually end up with the number 9. The other thing we need to understand is the correct order of operations. The order of operations is parentheses, exponents, multiply, divide, in order from left to right, and then look at these things in order. You're going to first do the multiply or divide, depending on where they come left to right in your expression, and then you're going to add or subtract in order from left to right. Let's look at a few examples. First one here, you have the square root of x plus 3, and it says that the value for x is 13. So let's take a look at this. Very important as you go through to make sure that we show some work. All right. So let's look at this example here. And the first thing that I want to do here on this is I'm going to get rid of my variable. So I'm going to replace or substitute whatever values we have for the variable. So in this case, we have a variable x is 13. So instead of writing the square root of x plus 3, I'm going to write 13 plus 3. Now, one thing you need to understand about this is it's understood that under a square root sign, there is parentheses, even though they're not written. So what you're going to actually do first is you're going to actually add the 13 and the 3 together. So 13 and 3 make 16. And then you're going to take the square root of 16. The square root of 16 is 4. So when we evaluate this, we get a value of 4. Let's look at another one. We have here x plus 5, where the x value is 16. So again, what you want to do here is you're going to replace your variable. So we only have one variable, it's x. We're going to write 16 there because that's what x is. And then add 5. 16 and 5, 21. Let's look at a few more. Let's look at number 3 here. It says h, and then in parentheses, b1 plus b2 end parentheses all over 2. Now, a couple things before we get going on this that I want you to know. First off, this b1 here and b2 here, the reason you have those there, those are not exponents. The only reason those are there is to allow us to understand, okay, b1 and b2 are separate variables. That's like x and y. It's not telling us to do any operation with these things. It's just saying that, okay, they're two different variables. That's all that's saying. So let's look at an example here, this example, and we know that h is 3, so let's put in 3 for h. And we're going to rewrite this again, getting rid of our variables. We know that b1 is 4. We know that b2 is 7. So again, we're going to replace those all over 2. All right? Now this is where order of operations becomes very important. You're going to do the parentheses piece first, because parentheses come before anything else in order of operations. So we're going to do the parentheses piece first. 4 and 7 add up to 11, and then we're going to bring our 3 down. They're still in parentheses, so I'm going to write this 11 in parentheses all over 2, just recopying the rest of this problem. So we did the parentheses piece first. Next thing we're going to do is we don't have any exponents, so now we're going to multiply in order left to right, or top to bottom. So we're going to multiply here. Now, another piece I need to let you guys understand, this is written as a fraction. There is implied parentheses or braces around the numerator and denominator here. So what that means is we're going to treat the numerator, we're going to simplify the numerator and the denominator separately, and then at the end divide. So we're going to do this in order. So 3 times 11, that's 33, all over 2. And 33 divided by 2 is 16.5. And there's your answer. Let's look at another example. This one I'd like you to try on your own, and then you'll have to pause the video and then come back and check it, okay? The first thing you're going to do here is take care of your parentheses, 4 plus 7. 4 plus 3. 4 plus 3 is 7. And let's make sure that I have the right pen here. 4 plus 3 is 7. All right. I'm going to recopy the rest of this. And then the next thing we're going to do is we're going to take care of the exponent piece. Parentheses first, then exponent. The exponent here is 2. So we're going to do 7 squared. 7 squared is 49. Bring your 2 down. And your 957. And the next thing we have to do, after we do that, is we're going to multiply or divide in order from left to right. The only multiplication we have is this 2 times 49, which is 98. Bring down your 957. And 957 minus 98 is 859.